Hello, we're back again. We're going back to my retirement example. Remember, I'm an old guy, 61 years old. Hope to retire in 5 years. So my planning horizon, this is what we call my planning horizon to accumulate money in my IRA and retirement assets is 5 years. All right, when I will be 66 years and 4 months, which is my full Social Security age to collect full benefits. Now, as I showed you earlier, is that my wife and I have about $1 million. And if I were to get 5%, which is it's a conservative number. If you can get 5% a year, that's good. Try to get a little bit more. You want to make sure it's always above inflation. So the $1 million will result in $1.276 million. Now remember, we talked about this A. If I were to continue with my what is called a defined contribution retirement, $15,600 a year contribution, that would result in another $86,000. Now I'm up to 1.362. I really like to get 1.5 million. I will show you later an example of why I would like to get to that. And however, if I don't get to it, it's not the end of the world. It's okay. We will be perfectly fine. All right. There's one other vehicle I can use to increase this, by the way. And it's called a G for gradient. So let's do the G now. Okay, at the university here, we average about 1.5% raise, which is nice. Okay, what I'm going to do for this example is I'm going to assume a 2% raise at the end of the first year. Then I'm going to use what is called an arithmetic gradient, G, for the remaining years. All right, okay, so what that means is this. I have a F sub 3. Why is that 3? Because the F sub 1 was for the P, F sub 2 was for the A. F sub 3 is now for my G. Now notice this. By the way, these are not to scale. Obviously, they're not to scale, okay? All right. So what is my G? So what is 2% of my first A of $15,600 is equal to $312. So this is what I'm going to call a G. And why is it called arithmetic gradient? Because with an arithmetic gradient, you're adding a constant each period to the previous period. A geometric gradient is you're multiplying by a constant. Now in reality, arithmetic gradients are not as common as geometric gradients. However, in this course and in the book, they use arithmetic gradients, and also it's used most commonly in this type of class, so we'll just do the arithmetic. However, if you do want to find out about the geometric gradient, you go to Newton's book. On the back side of his equation sheet, there is a geometric series present worth, which is really the geometric gradient, which means you multiply it by a constant at the end of each year. Okay? All right. So what we're going to be doing is this. We're going to be adding $312 at the end of year 2. A gradient is intended to be built upon a uniform series, whether it goes up or whether it goes down. And that's why it skips the first year. It skips year 1 or period 1. Now, we add another constant, another 312, so we're now up to 624 at the end of the third year. And here, we're adding 936 at the end of the fourth, and 1,248. What this is 2 G's, 3 G's, 4 G's. But the G is called, or has $312. Notice this, that this is n minus 1 g's. And why is it not ng? Because it skips the first year. All right? Okay. So, how are we going to solve for this? Here's my cash flow diagram. All right. So, what we're going to do is this. We have an F. We don't know yet. We have to solve for it. We do have a G. We have an N is equal to 5, and we have an I is equal to 5%. So let's find out what the F is. Oh, I'll just go to the tables, and I'll go here. F is equal to G times, get rid of the G, keep the F, 5%, 5. And now I'm going to go to the tables here. I'll go to 5% page. Okay, we got F over P, A over... Oh, we got a... Well, wait a minute. There is no F over G. There's a P over G. There's an A over G. Does that mean we give up? Absolutely not. None of us are quitters. So here's what we have to do, is we have to do an intermediary step to get to that F over G. All right? So what I'm going to do now is this. I'm going to draw a new cash flow diagram, and I'm going to calculate the P for my gradient. All right, so my P is equal to G times P over G, 5%, 5. That's 312 times P over G, 5%, 5. Now let's go to the 5% page. Oh, there is a P over G. Good. And 5, it's 8.237. So my P is equal to $2,570. Now, ladies and gentlemen, that is the present value of the amount of these G's. And there really are 10 G's, because you take 1G plus 2G plus 3G plus 4G. The sum is equal to 10 G's. And that is equal to 10 times 312, which is $3,120. Now, you know the P has to be less than that, right? Because this is a loan. The sum of the bottom is greater than the sum of the top in a loan, as we learned previously, one of the two fundamental types of cash flow diagrams. Do we stop here? No. This is step 1. Step 2 is we now are going to calculate the F from the P. So here's what we have, ladies and gentlemen. The P is 2,570. What is my F? Let me go to the next page. Okay, remember there's two ways of doing it, particularly for the F over P's. You can easily do it with the equation, or you can use the tables. Let's use the tables. All right, that is my P. Now I want to get rid of the P's, keep the F. All right, and what is that? F over P. It is, as we showed you last time, it's 1.276. And what we now know is this. The F is equal to 3,279. So let's put this in context, going back to my retirement example. Okay? All right, so remember, so my retirement is, what we had was a P. This was $1 million. My F is 1.276 million. This is assuming 5%, 5 years. Then what we did is I said, all right, because of that's F1. F2 was 86,206. That was from my future contributions of $15,600 at the end of each year for 5 years at 5% a year. And then the last is this, is my f sub 3, remember these are not to scale. F sub 3, and my g was 312, and this is a very small amount. This is 3,279. So if you add them all up, and that's the wonderful thing about cash flow diagrams, is that they're additive and subtractive, but you need to make sure where you put your zero, and you need to make sure of each time period. So if you add all those up, what does it come to? It comes to $1,365,485, which is a nice sum of money. It's not my 1.5% goal, 1.5 million I mean, but that's okay. How can you get 1.5 million? You have to increase the I. Maybe 6%, maybe a 7%. And what happens is when you increase the I, the additional money you get increases non-linearly, and it grows very, very quickly. Okay, so what I've shown you is the example of with my retirement, and what did we really do? We did an F over P, we did a P over F, we did an A over F, we did an F over A, right? We also did a P over G. There's also a G over P. There's also an A over G and a G over A. Those are not used too commonly, so I won't review those right here. So we have covered all of that, plus our basic equation here.